Okay, so this is 2.4. We are going to look at slopes of parallel and slopes of perpendicular lines. And before we do this, we need to talk about slope-intercept form. Slope-intercept form is y equals mx plus b. M is slope, and b is the y-intercept. And the other thing I want you to look at is the y and the x. The y and the x stand for any point on that line. Okay? All right, so slopes of parallel lines have the same slope. Parallel lines have the same slope. Slopes of perpendicular lines have opposite reciprocal slopes. Okay, so opposite means sign. So if it's positive, it becomes negative. It's negative, becomes positive. Reciprocal means you're flipping the fraction. So for instance, 3/4, the opposite reciprocal is negative 4/3. Positive 5 becomes negative 1/5. Negative 1/3 becomes positive 3/1. All right, so if we look at this, we say, here we have a ski lift. It's 20 feet above the ground. It goes up the hill, has a slope of 1/2. All right, so the y-intercept is right here, and that's 20. And then we have a slope of 1/2, right? So the equation on the line is y equals 1/2 x plus 20. Here, the slope-intercept is 0. And again, the slope is still 1/2, so y equals 1/2 x plus 0. But we never write the plus 0, so your equation would look just like this. All right, so I want you to look at these words right here. Because the slope is 1/2, the hill gains 1 foot in height, right? Because slope is y over x for every 2 feet of horizontal movement. And you see this here, up 1, over 2, and up 1. Okay? So if two linear equations have the same slope, then the graphs of the equations are parallel. All right, so two non-vertical lines are parallel if and only if their slopes are equal. Vertical lines are parallel. Okay? Now let's talk about vertical line slopes though. If you remember, the slopes are undefined. Okay? All right, so let's find the slope of K. So if you're looking at a graph, the easiest way to find the slope is to find a place where it goes through and then find another place. Always start with your left-hand point. 1, 2, 3, 4, 5. That's down 5 over 1, 2, 3, 4. So always remember slope is y over x. Now you can also do this by points. Remember, y minus y over x minus x. And actually find the coordinate point. I think it's easier if you're given a graph, just to say I'm going down 5 and over 4. Slope n, we'll do n the other way though. Let's find 2 points. Here's a point, I'm going to call that 1, 2. And here's a point, we'll call that 4, negative 2. So slope equals y minus y over x minus x. And I get 4 over negative 3. Okay, if I went down 1, 2, 3, 4 over 1, 2, 3. So see it down 4 over 3. I'm still getting that negative. So if I compare these slopes, they are not the same. So these guys are not parallel. Even though they may look like it in the picture. Now it wants to know if M and Q are parallel. So you check M and Q and then come back and see if your answer is right. All right, so one of the slopes was 2 over 6, which was 1/3, and the other slope was 2 over 5, which is, no, those are not the same slopes, so the lines are not parallel. All right, so here, if Theorem 214, 2 non-vertical lines are perpendicular, if and only if their product of their slopes is negative 1. And I called this the opposite reciprocal earlier. So if we look at one of those examples, I think I did 4/5 and negative 5/4, something like that, and I get negative 20 over 20, which is negative 1. A horizontal and vertical. Here's a horizontal, and here's the vertical. They are perpendicular to each other. That is a slope, an undefined slope, and a slope of 0. Okay, so let's check for perpendicular. Find the slope of J. All right, so here is J. I'm going to go from here to here, I think. 1, 2, 3. Down 3 over 2. And then find the slope of K. Let's see. K is here. And here. 1, 2. 1, 2, 3. So the slope of K is positive 2/3. So negative 3/2 and 2/3 are opposite reciprocal slopes. And if I multiply them, I get negative 6 over 6, which is negative 1. So yes, they are perpendicular. All right, so I want you guys to try H and L, and K and M, and then come back and check your answers. All right, so H and L is no, and K and M is no. Now we are going to write equations of parallel and perpendicular lines. So the first thing we're going to do is identify the slope of the parallel line. So what we want to do is, well, first let's read the question. What is an equation of the line through P that is parallel to L? So we want through P parallel to L. So we want an equation of this line, okay? So first an equation of a line, let's also do this, is y equals mx plus b, okay? So, and in any y equals mx plus b, I need a number here and a number here. So I know I can get m, that's the slope. So slope is going to be the same as the parallel line, so 1/2. And then we're going to solve for the y-intercept, okay? Because if we look at this, I have y equals 1/2 x plus b. I need b, okay? And I can kind of find it. I could graph it. But the only other thing that they gave me here was an x and a y. So I'm going to plug in the 1 for y and the 4 for x. And I'm going to solve for b. So 1 equals 2 plus b. Subtract 2 from both sides. And I get -1 equals b. So my equation of this line is y equals 1/2 x minus 1. Okay, so now same thing. Let me erase this, but I want a perpendicular line. So I'm going to draw a line. I need the equation of a line that's like this, right? That's perpendicular to this line. So the perpendicular line would have to be the opposite reciprocal. So -2/1. And again, I start with y equals -2x plus b. And I'm still going to use that point that I know it goes through. 1 equals -2 times 4 plus b. So 1 equals -8 plus b. And my equation will be y equals -2x plus 9. So I need you, and I'm going to work with these with you, but in class. So I'm not doing them here. We're going to do them in class together. Parallel lines. If and only if the slopes are the same. Perpendicular lines, if the products of the two slopes is -1. All right, we will see you tomorrow.